Hey everybody, this is Mr. Munson and we are in Unit 5, Congruent Triangles. And so in this concept, which is this video, concept number 4, we're going to deal with isosceles triangles. Pretty straightforward. You probably have a basic understanding of this already from some previous information, but we're going to solidify it, come to work through some a little bit more difficult questions and problems than we've had in the past, and just make sure that you understand this. All right, let's get started. All right, first up, let's just make sure that you got the vocabulary words, right? So when we look at this problem here, or this information, in an isosceles triangle, you need to understand when I say in words certain things that it's not drawn into the picture. If I say, certain side or legs, you need to understand that when I'm talking about isosceles triangle, the legs are always the two pieces, the two sides that are congruent to each other. And then the angles that are opposite those sides are called base angles, right? Base angles. And what we find out in this unit is that base angles are congruent. So now let's take a look at this example. So I have two sides that are congruent, and so I want to, let's say, list the two sides. Now since it's a list, I'll put AB with a bar above it, because we're talking about the name of the sides. AB and AC are called the legs. Now, name the base angles. Now, this is really important. This is where I've turned the triangle kind of sideways compared to the figure up above here, so that you understand that these angles down here at the bottom are called base angles, not because they're at the bottom of the triangle, but because they're opposite the congruent sides. So if you look at the drawing here, the base angles are going to be C and B. Now, just to help us visualize this, and I encourage you to do this, draw circles around the congruent sides and point to the congruent angles. And so you could walk in, if I gave you this problem, the next step would be maybe to mark these angles congruent so you can see that, right? So the base angles are called angle C and angle B. Now, the reason I know that those angles are going to be congruent is because in previous work where we're ordering the sides, we found that at times this, two sides would have the same length, and it would make kind of a tie between which angle was larger or not. And so we stacked them and made them the same, right? And so what I want you to know is that if the two sides of a triangle are congruent, then the angles opposite them are congruent. And if the angles are congruent, if you have two angles that are congruent, then the opposite sides are congruent. So let's put that more formally into a theorem. This is called the base angle theorem. Basically says this. If you have an isosceles triangle, then the base angles are congruent. And again, I can't say this enough. It's not base angles because they're at the bottom, but because they're opposite the congruent sides. All right, let's move on. All right, let's look at this example at the top here. We have some information given, and they want me to find the measure of AC. See, there's no bar above it, so I would use the word measure of AC. So let's take that 8.5, and put it into the drawing. So I'm going to write it right here, 8.5. Now I notice that these two angles, the 65 and the other one that's 65, those two angles are congruent. So this is what I know. At the very least, this triangle has two sides that are congruent. At the very least, it's isosceles, right? And so what I'm going to do is I'm going to grab those angles, and I'm just going to point to the opposite side so I can make sure I identify correctly which sides are congruent to each other. So the 8.5 has an arrow pointing to it. That means the other arrow is pointing to another 8.5. Now, I'm not sure what this side's going to be, and it could be the need for some additional information to get me there. But for right now, this is what I know. AC is 8.5. Okay, now let's take a look at this next example. This one, in the previous example, we're given that the angles are congruent. We're given that information to lead us to information about the sides. So now what I'm going to do is lead you from knowing that the sides are congruent. That's going to help me to deal with the angles. Okay, so they want you to find x. Now, to the inexperienced geometry student, they would think that x might be equal to 75, but it's not. Let's just make sure that we do the graphics to help ourselves be correct. I'm going to draw circle around the congruent sides and point. That will tell me which angles are supposed to be congruent to each other. And sure enough, x is not 75. That other angle is 75. So using the triangle sum theorem, I know that those three angles have to add up to 75 degrees. I mean, add up to 180. So after doing the math of that, I find out that x is equal to 30 degrees. And that's how I do that kind of problem. All right, here you go. Here's an example. I want you to try it. And so, again, I encourage you to circle those two congruent pieces and point to the angles to make sure that you know which ones are supposed to be congruent, and then do everything you can to figure out what x and y is. Well, indeed, x and y are congruent to each other in this one. And so what I would do is I would take that x and y, I could add them up to equal 180. The problem with that equation is that I have two unknowns. But since they're congruent to each other, since the two variables are congruent to each other, if it's all right with you, I'll just call this one x. They're the same thing. X and y are congruent to each other. So I end up with 2x equals 140, and therefore x and y are equal to 70. Now, I like problems like this because you're really given more information than you need to play with. But students will feel required for some reason that they have to include all those sides in their equation, the 7x plus 2, the 5x minus 1, the 3x plus 7, that they'll put those all together in one equation. And it's really unnecessary and impossible. It's not logically possible. One of the number one errors students will have right now is they'll actually add up those expressions and make them equal to 180. And I need you not to be that student. That's just crazy talk. This is outside the triangle like this. This is representing a side length. And sides do not add up to 180. Angles inside, those measures in there add up to 180. So please don't do that. But what I'm going to do is I'm going to realize that this angle here points to a side that's congruent to this one. Okay? So this is what I know. I know that those two sides are congruent to each other, which screams at me to say that those two expressions are equal to each other. And now I just simply solve that. Now, one of the things I want you to know is we never use this. Now, if they had asked me to find all the sides, the length of all the sides, then I still would have started with this equation. Even though they want me to find out each side, and I'm going to eventually have to use that 7x plus 2, I would simply use the equation that says, hey, these two sides are equal to each other. I'd find that 4, and then I would plug it back into each one of those sides and find out what each individual side is. It's that simple. All right, have a go at this one. Notice that you have a 7 on those two sides. That means those two things are congruent, so you might make those congruent marks. And then see if you can write an equation and eventually solve for what the angle A is. All right, have a go at that. Well, you might not have found the y yet, but I've stopped you, and I just want to make sure that you have the x right. So if you didn't get the x right, I want to make sure you have a go at the y to get points. So let me show you how you should have gotten the x. First up, I'm going to point to these sides being congruent, right? And point to the opposite angles. So I know the relationship I can write is going to be these two things are equal to each other. So when I solve that, I get x equals 10. But that's not going to help me find y. But what I can do is plug it in for these two angles and find out what the real numbers are. And once I've done that, then I can look at some previous information to find y. See if you can do that now. And there you have it. So I found out what x is, and then I plugged it in, and I got those two base angles to be 32. Now, again, these are not base angles because they sit at the bottom of the triangle. They're base angles because they're opposite the congruent sides. Okay? They just happen to be at the bottom. So now I have those two angles. I can simply write the triangle sum problem that says that 4y plus that 64, 4y plus 64, that's both those angles added together now, 64 is equal to 180. And so now it's just a matter of solving that. And there I have it. Y equals 29. And that's it. So here's your do it problems. And so what I want you to do is go ahead and do it. Do these problems on your own. And we'll check to see what kind of questions you have next class.